So here's what happened. At my school, we have these overpriced pieces of Microsoft which have been restricted to uselessness, but which they still insist on calling laptops. Like, seriously, this is supposed to be a work tool? I can't even use the PowerShell. I can't even run executables. I don't have and can't download an IDE. Well, at least I have a browser. Except we can't watch videos or access Quora, Reddit, GitHub, Commons, AIs, Clipchamp, Gmail. You know, this is just a freaking toy. Like, not even that, every game is blocked, it's a piece of metal. Well, at least we have our trusty phones as our only digital toolbox. Except here, they are illegal! Anyway, so I was talking with the principal, and I asked him, hey, if I built my own cell phone, would I be able to use it here? And to my elation, he said yes. Did he maybe think I wouldn't? I've always found this kind of wearable displays you see on TV extremely cool and high-tech, so I decided to use that as the format for my device. So here's how I did it. I had a Raspberry Pi Zero 2W lying around, basically a potato with 512 megabytes of RAM, but that wasn't gonna stop me. What I needed was a screen. I took apart an old cell phone for fun and extracted the screen, but it turns out big companies' phones aren't really open source, so there was no way I'd be able to get it working myself, never mind on a different operating system. I did come across this adapter shield, which might have worked, but just buying a cheap screen would end up costing just as much. So I got this 4-inch capacitive touchscreen, which uses the ST7796's driver for display and the FT6336U's driver for touch. But of course, any portable device needs a battery. Luckily, I had bought the Pi Power hat with the intention of using it for my robot, but ended up making my own battery system instead, so it came in real handy. Once the screen arrived, I made a wiring plan for everything. I'd have to solder the wires, as the Pi has no headers, although that might have been a good thing because they would have taken up a lot of space. In fact, to make my setup as compact as possible, I removed pieces of the Pi Power which stuck out, but I wasn't going to use. The thing is, I suck at soldering, so after having the entire set of headers go completely loose twice, I decided to order flux for the first time. Now, it might have been a bit of a placebo effect, but it finally stuck. Aren't those some beautiful joints? Now, with the screen wired, I could start coding. So I flashed the Raspberry Pi OS onto an SD card, and here's where the actual nightmare started. You see, to use any piece of hardware on Linux, you need two things: a device driver, which is part of the kernel, and an overlay, which describes how that driver should interact with the device. Now, luckily, there was already a driver compatible with the ST7796S called Panel MIPI DBI and an overlay for it called MIPI DBI SPI, so I only had to add that specifying the GPIO pins I'd chosen, and it worked right away. No, the problem was the touch, because it turns out there was no driver and no overlay for the FT6336U, despite the fact that it said Raspberry Pi compatible in the product description. Not only that, but when I tried to detect the driver through the I2C interface, just a method of communication, nothing showed up. Thinking it might be because I hadn't actually activated the thing with the overlay or whatnot, I started scouring the internet, trying overlays from the driver from other operating systems, adaptations from overlays for similar drivers, making my own overlay, but nothing worked. Along the way, I found out the EDT FT5X06 driver from the Raspberry Pi could be compatible with the FT6336U, which is nice, but the fact is it wasn't working. Not only that, but my screen kept fluctuating and going blank. After a lot of multimetering, I realized two things. First, I had fried one of the two pins used for I2C, SDA, and second, my ground joint was loose. You see, in the screen's datasheet, it said it could work with 5 volts, so I just used that as power. However, the I2C pins use 3.3 volt logic, and yeah, that killed them. So I had to change the power pin, change the I2C pins, resolder the ground pin, and then modify the entire overlay, as I was no longer using the default I2C pins and thus had to code my own interface. And after all that, my I2C interface was unstable. Turns out I still had a few loose joints, oh my god! So I finally locked in, used a new head, cleaned with ethyl alcohol because I don't have isopropyl gum, but who cares, flux, and bam, now everything worked. I could finally touch my screen and quit soldering for the next 2 months. Now that all that was sorted out, I made the case. I roughly measured my arm and came up with a system to fasten the bracelet with Velcro, made the absolute most compact case possible with a hole for the charging port, one for the USB that sticks out, one for the cables to the battery, one for looking at the battery indicator LEDs from the Pi Power, and one for the Pi Power's on-off switch. I then imprinted my logo on it and started printing while I researched on the software I'd install. And once the case was finished, I put my hardware into it, closed it and sealed it, created a couple custom Velcro strips to fix it to my arm, and made this aesthetic case for my battery. I attached it to the side of the bracelet, and now it's officially more handsome than me. I then began with the fun part, the apps. So I knew this would be tricky, as I said, the Pi 02W only has 512 MB of RAM. For the uninitiated, that's about as much as what's in the iPhone 4, the Nokia Lumia 520, or the original Apple Watch. So it's not really meant to be too much of a PC, but again, that wouldn't stop me. The first thing I needed was a browser. The default browser, Chromium, literally warned me not to open it, which, great. So I started looking at extremely lightweight browsers and landed on Epiphany, Chrome's default browser. After installing it, it did open, although that took a literal minute, and although I was able to search and load some pages, they quickly went unresponsive and crashed. To try and solve this, I used ZRAM, which is basically compressed RAM, which allows you to triplicate the amount of RAM you can use. I used the algorithm from the More RAM app from Pi Apps, basically the App Store for Raspberry Pi, but Epiphany still ran extremely slow, so I needed a new plan. And after some more research, I found Puffin. Puffin is a bit of a special browser, because instead of letting your device render websites, it does that in the cloud, meaning that my Pi would need to do basically nothing. Although, PSA, if you use this, all the data you enter can technically be intercepted and stolen, so yeah, just be careful. Inside Puffin, I was able to access Google Search, YouTube, Gmail, and most other websites. However, some of them, like Discord, WhatsApp, or Spotify, were not compatible with the old user agent used by Puffin. So for Discord, what I did was try to use Legcord, a lightweight desktop client from Pi Apps. But that went even worse than Epiphany. So I used an app called Discross, which I added to my servers and which allowed me to access them and send messages to them from the Discross website, which supports old user agents. For Spotify, I just used YouTube Music. Now you might have noticed the Pi Zero has no speakers, but fortunately it has built-in Bluetooth, so I was able to connect it to my headphones, which gave me a lot more trouble than it should have. But apart from messaging, I wanted to be able to call. Given that I don't have a SIM card, I'd need to use a voice over IP service. Luckily, there's a lightweight VoIP app available on both Raspberry Pi and Android called Linphone. I set up some accounts for my parents and for me, each with their own address, added them to my Linphone contacts, and was actually able to make a voice call to their phone from my bracelet. Next up, games, of course. The first thing I did was go straight to the terminal and install Doom. And it worked, so we've officially run Doom on a bracelet. I also installed some other lightweight games, like Frozen Bubble, Neverable, Numtai Physics and Super Tux, and they're quite fun. Kinda feels like playing old Wii games. So then my bracelet was pretty much ready. I brought it to school, connected it to the Wi-Fi because I know the password because I'm that cool, and Puffin didn't work. So I extracted some logs and stored them in files to analyze them at home. Now back at home, I figured my troubles were caused by the school network using TLS inspection and plopping darn near everything. Let me explain. So every time you access a website, it presents a certificate to your device. However, the device will only accept it if it's signed by a trusted certificate authority, the list of which you can actually check out in your settings. However, when a network uses TLS inspection, it intercepts any request your device makes, presenting its own certificate to it, and only then sends them to where you actually wanted them to go. It's literally a man-in-the-middle attack, and it allows the school to see every single thing we do online. Now, most devices and apps simply accept these new certificates and roll with it, but not Puffin. Now, it was hard to figure out why, because there's no documentation, no contact page, no debug output, no logs, no terminal options, and only a couple painfully generic errors with typos. But I've come to believe it uses certificate pinning, meaning that it won't take any certificates by authorities not setting the app's code itself. Because of this, I needed to avoid TLS inspection entirely. Normally, one would use a VPN to do this, but this was tricky because the network also has a firewall blocking basically every port. But one exception was port 443, the port used by HTTPS. That's right, IT, block that and you block Google. How about that? And I had two main options. Use a SOX 5 proxy to make an SSH tunnel through port 443, for which I needed to get a dedicated server, which I unsuccessfully tried to get by making automated requests to Oracle Cloud for a total of like 60 hours, or try to use a VPN on that port and hope its traffic wasn't blocked by the network. So while I kept sending requests to Oracle, I tried Proton VPN on port 443, and it worked! I could now use my bracelet's most powerful tool. I automated the VPN connection, and with that and a dope new background, my job was done. I am now the only kid at school who can watch YouTube, chat through Discord, or access GitHub. Interestingly, in the RMB, the first thing my classmates did was call it trash and or try to get it banned so I couldn't use it. So that's how society is these days. Anyway, please like and subscribe. I think this was one of the coolest projects I've ever made, and I have huge things planned for the future, so I'll see you in the next one.